Good morning, all. I request all participants to mute your audio during the session. At the end of the session, you all can unmute and ask queries with the presenter. Once again, good morning, all. I welcome all participants to the webinar series on
Thank you. Good
organized by
morning.
Department of Computer Science and Engineering, LBS College of Engineering, Kasaragod. Today's session is about natural language processing and its application. The session will be handled by Mr. Premjith B, Faculty Associate, Center for Computational Engineering and Natural Networking Department, AMRITA University, Coimbatore. His research area includes machine translation, natural language processing, deep learning, machine learning, etc. On behalf of our college, I welcome you, sir, to the session. So we are moving to the session. Over to you, sir.
Am I audible to you?
Yes, sir, you're audible.
Okay. Thank you, sir. Good morning, everyone. Welcome to the webinar on Introduction to Natural Language Processing and its Applications. I will start with the definition of the language given in the Cambridge Dictionary. It says that language is the one that has developed in the usual way as a method of communicating between people rather than language that has been created. For example, the language created for computers, programming languages. The major difference between the natural language and programming language is the number of vocabulary and the structure. Natural language usually contains infinite number of words, whereas programming language contains a limited number of words. And programming language usually follows a predefined structure, but our natural language doesn't follow a predefined structure, especially the Indian languages. We don't follow a subject verb object or subject object verb structure. Natural language usually are free word order languages. So why this language is very important? We use it in each moment of our lives in one way or the other. We need natural languages to speak, to read, to write, to think, or even to dream. So we use it for everything. So what is natural language processing then? The main objective of natural language processing is to improve human-machine interaction. We all use applications like Google Assistant, Apple Siri, right? How do they work? We ask or type some queries to their text boxes, and they process it and respond to us as if we are interacting with another human being. Okay, NLP is the technology which works behind these applications. NLP is defined as the computational processing of natural languages. The word computational processing means that it is nothing but the identification of the semantics or meanings, context, and syntax of a text. Actually, NLP is an interdisciplinary field which requires the skills in computational linguistics, computer science, and artificial intelligence. Computational linguistics deals with the linguistic side. In this area, we study the formation of words, the structure of a sentence, the pronunciation of words, etc. Technically speaking, we can talk like syntax, semantics, phonology, phonetics, etc., or morphology also. So it also deals with the socio-linguistic features, geographical features, and psychological features of the language. Computer science skills helps in programming and designing the algorithms. And the artificial intelligence, it is the core of this natural language processing. And the AI technologies help computers learn natural languages using various algorithms. So why this NLP is interesting? This image is an old statistics, 1-year-old statistics. You can see that billions of petabytes of data are being shared on the internet a day. So we can extract a lot of information from this data and make some intelligent decisions. We can translate text in one language to another, or we can identify the fake contents among these data, or we can identify the emotions of the users from their social media post. In this way, we can find n number of applications out of this data. So the question is NLP alone is sufficient for dealing with the languages? My answer is no. So NLP and associated concepts like natural language understanding, natural language generation are essential for the effective processing of the natural languages. So among these, natural language processing is the most important. I can explain these concepts with the help of an example of conversational agents. When we talk to an agent, conversation agent or chatbot, the agent reads our text, okay, and split it into words. This is a fundamental, one of the fundamental step in any NLP task. When we have a text, we split the sentence into words or chunks. The chunks can be words and punctuations, etc. So once you convert the sentence into these chunks, we represent these as a vector. There are a lot of methods to represent these words or punctuations into some vector representation. Initially, we were using methods like bag of words, n-gram features, term frequency, inverse document frequency, scores, etc. But nowadays we are using algorithms like word to vec, fast text, BERT, Ernie, Elmo, Muse, etc. These algorithms are neural network based algorithms. The advantage of these these methods are they can capture the context and semantics of the words and sentences. So once you represent words as a vector, we can represent sentence as a sequence of vectors or as a single contextual vector. Okay, the single contextual vector can be generated in multiple ways. The one way is to take the linear combination of the word vectors. So this is all about NLP. So in the next step, once you convert text into some vector representation using natural language understanding concepts, the machine identify the vectors similar to the answers for the queries. Okay, the natural language generation step converts those vectors into a sequence of natural language words, which will be the answers to our queries to the agent. So NLP in industry. So this is a graph showing the funding in different domains. You can see that NLP has around $660 million funding. This was in 2017. And you can see the share of NLP technologies in the AI market. 24% of the technologies are related to NLP, voice recognition and response solutions. Speech processing is a part of natural language processing. Then what are the industries using NLP? Healthcare, finance, legal, translation systems, cybersecurity, marketing intelligence, hiring and recruitment, advertising, application word processing tools like Microsoft Word, Google Docs, Grammarly, search engines, voice assistants, news feeds, etc. So one news is that in the USA, advocates are under tremendous pressure since IBM Watson starts giving better legal advice than advocates. In healthcare also, we can apply NLP left and right, especially for the task like DNA sequence analysis. A DNA sequence contains a sequence of four letters C, G, A, T, cytosine, guanine, adenine, and thymine. So since the DNA sequence contains a sequence of these four letters, we can apply NLP technologies to mine the information from the DNA. So in cybersecurity also, most of the logs are in the form of text, and we can use NLP algorithms to find the hidden patterns in the cybersecurity related content. Human resource department can use NLP to select the best resume which matches with their criteria. So almost all the industries, wherever we use language as a part of their work, we can apply NLP technologies. So this graph shows the significance of NLP in healthcare domain. In 2017, the share of NLP technologies is very less, but in 2027, there is a forecast. In 2027, you can see that healthcare domain is entirely driven by the NLP technologies. So this slide shows the average salary of an NLP engineer in India, 9.89 lakh per annum. So even though we use natural language every day in every second, the natural language processing is very hard because Human languages are highly dynamic, mysterious, highly non-linear, very complex in structure, etc. So because of these reasons, NLP is very hard. There are a lot more reasons to this condition. And one of the major objective of any NLP task is the deep understanding of the knowledge. So the deep understanding means the deep understanding of the context, linguistic structure, meaning, etc. But in reality, we'll have a shallow matching. Okay, the machine will not be able to identify the proper context from the text. Even though English has achieved a lot success in the natural language processing task, but for Indian languages, we haven't achieved the state of the results in most of the NLP algorithms, NLP applications. So text is always a superficial thing. So when we see a text, we can see an abstract idea of the text only. But actually, a text is like this. There are a lot of hidden information present inside the text, meaning-wise and context-wise and syntax level, structure level also. So the major problem of NLP being hard is the ambiguity. We can find the ambiguity at all the levels of natural language processing. So most important ambiguity is the word sense ambiguity. So the word sense ambiguity is the word can have multiple meanings in multiple contexts. So identification of the proper meaning of a word is a difficult task. So when you train a model, chatbot thing, if it is not trained properly, when you say call me a cab, it will start calling you a cab. So in the example sentence, you can see that on the other hand, you have different fingers. The meaning of other hand, the phrase other hand, we can understand the meaning, but the computer may not be able to understand the proper meaning of the other hand. We must polish the Polish furniture. The second polish is related to the country Poland. And they were too close to the door to close it. These two clauses have two different meanings. So train the computer and teach them to learn the proper meaning of the words in different contexts is a very difficult task because of this word sense ambiguity problem. And ambiguity can be found in the syntax level also. Sanjo's cops kill man with knife. We can interpret this sentence in multiple ways. Sanjo's cops kill a man using a knife, and Sanjo's cops kill a man who is having a knife. So we can interpret the sentence in two ways. Another ambiguity is at the discourse level. So Dr. McLean often brings his dog Charmin to visit with the patients. He just loves to give big, wet, sloppy kisses. So to whom this he refers to, Dr. McLean or the dog champion? There is a confusion. This is confusing for us also. So think about the computers. And another ambiguity is at the phonetics level and phonology level. Phonetics deal with the production of speech sounds, and phonology is about patterns of sound. So when you say ice cream and ice cream, so the computer should be trained in such a way that it should identify the subtle pauses in between I and ice. Then only they can understand what exactly we speak to them. Okay. Then morphological level also we can find a different level of ambiguity. So morphology is the study of how words are formed in a language. Okay, this is very important in understanding the better understanding the meaning of a word. When you split a word into its consonant morphemes, we will get more information related to this. So morphemes are the smallest meaning we are unit in a language. So morphemes can be suffixes, prefixes, or infixes. So when you segment a word, understandable, it can be segmented as understand plus able or under plus standable. All these are English words. So we should understand what is the perfect splitting method criteria. What are the in which way we have to split the word to understand the proper meaning of the word. So here able is a suffix. So in unionized, we can segment it as un plus ionized or union plus iced. Here un is a prefix, and that is the correct form. So we should train the computer in such a way that it should understand the proper splitting of the words. Then only it will be able to identify the exact meaning of the words. This is very important in the computational processing of the Indian languages, morphological splitting. So pragmatics, it is another level of complexity. Pragmatics is the study of what people meant, but it didn't explicitly say it. So how we interpret the sentence. Okay, that is all about pragmatics. For example, in Malayalam, we can say in the, it is a question in the, we can say it in another with another voice modulation. So the meaning or the context will be different for that particular voice modulation. So here you have one example: pruning a tree is a long process. This statement is related to the computer science, and it is not related to the cutting the actual physical tree. So by understanding the context, we should identify the meaning of the sentence. So these are the examples. You might have seen all these funny examples in social media. So people can interpret things in multiple ways. So that is about pragmatics. So another problem is quote mixing. So quote mixing usually happens in a social media post. Quote mixing is the it happens when we use words from multiple languages in a text. For example, when we speak, we mix Malayalam and English. When we type also, we use both Malayalam and English words. So if the computer model is trained using Malayalam words, when they see English words, they will be confused. They won't be able to generate proper representation for English words. This complexity increases when Malayalam words are written in Malayalam script and English words are written in English script. So the computer will have to deal with two different scripts. This complexity again increases when we write text in Manglish. Okay, Manglish means Malayalam script in Malayalam characters in English script. The computer will not be able to generate proper representation for these words because Manglish words are not present in the English vocabulary, and Malayalam doesn't have the English script, doesn't understand the English script. And another problem is non-linguistic pattern. Actually, in Indian language scenario, we don't follow the proper structure for the sentences. So that will cause some problem or ambiguity in the NLP applications. Then lack of annotated data. It is one of the most important problem associated with the NLP task. Most of the natural language processing tasks are classification tasks or supervised learning tasks. So classification tasks require labeled data set. But for most of the NLP tasks, we don't have sufficient annotated data. With the advent of deep learning algorithms, we need huge amount of data to train a computer model or a machine learning model. But we don't have such data set for many of the applications, especially in the Indian language scenario. Neologism. Every day we can have different new words coming up. So the algorithm have to deal with the new words. Sometimes algorithms won't be able to generate word representations for new words since most of the words may not be available in the corpus or dataset. And abbreviations, usage of abbreviations or short forms. LOL, G2G, BFN, B4, and etc. are the standard short forms. We can resolve these standard short forms using the help of a dictionary. But there are some short forms which are user-specific short forms. So it will be very difficult for even humans to resolve the user-specific or user-defined short forms. So NLP tasks can be classified in various levels. The first level is character level task. Example is character prediction. So in Google search, when you type some text, Google will predict the remaining sequence of characters. So that is an example for character level NLP applications. And word level, we have morphology. part of speech tagging, named entity recognition, stemming, and lemmatization. Morphology can also be implemented at the character level. And stemming and lemmatization, these two are the two fundamental NLP applications. Stemming and lemmatization will reduce words into some word base forms. For example, stem of studied, studied, word is study, studi. Okay, stem will uh, remove the suffixes. Okay, when ed is attached to the word study, we will get studied, studid. So when you remove ed from the word studied, it will be reduced to studi. So stem of studied is studi, whereas lemma of studied is study. So lemmatization will give you the root word of the word. Okay, so there is a slight difference between stemming and lemmatization. We can use stemming and lemmatization in NLP task to reduce the number of vocabulary. Okay, so studies, studied, studying, everything. When you apply stemming and lemmatization, all these words will be reduced to one single word, either study, studi, or study. And we can also do NLP tasks at the sentence level. Syntactic parsing, we have already seen the syntactic parsing. So at the discourse level also we can do NLP. Text summarization is an example for NLP at the discourse level. Then we will see the some NLP applications in this section. One of the important or fundamental NLP task is part of speech tagging, assigning each word in a sentence with the corresponding part of speech. So part of speech is known as word classes, syntactic categories, or grammatical categories. Examples are noun, verb, adjective, adverb, etc. We can categorize part of speech tags into two, closed classes and open classes. Open classes examples are nouns, verbs, adjectives, and adverbs. Why it is called open classes? It always accepts new words. We have already seen the neologisms, new words. So all those words belong to these categories. Whereas closed classes never accept new words. Okay, they will have a finite set of words in their category. Example, determiner, a and this, that, these, those, etc. So we have only fixed number of words in that category. Similarly, prepositions, a, at, on, in, for, etc. There are fixed closed class, or they have only a finite number of words in the category. Another important application is named entity recognition. So it is considered as a information extraction task. Okay, so it is the task of identifying the proper nouns from a text. Okay, in this example, the decision by the independent MP Andrew Wilkie to withdraw his support for the minority Labour. So from this example, you can see that the red color words are person names, green color represents state, blue color represents the organization, and purple color represents the location. So in general, named entity recognition extract the words such as person name, date, organization, location, etc. One of the most common example is when you book a train ticket using IRCTC website, it will send you a confirmation mail to your Gmail account. Okay, the Google Calendar extract your name, train name, train number, departure station, arrival station, departure time, arrival time, date, etc. from the Gmail. Okay, there will be a lot of other information in the Gmail. So Google Calendar extract only these information and add to the calendar. So that is a kind of named entity recognition or information extraction task. So the NER, here you can see that NER uses tags like person, date, organization, location, etc. These tasks depends on the domains. Okay, biomedical domain uses their own tags. Cybersecurity domain uses their own tags. For example, in biomedical, we can have tags like disease name, drug name, symptoms, etc. Okay, there are some problems with the named entity recognition task. One of the problem is date versus time. When you represent something like 10 dot 02.20. We can interpret this as a time as well as a date. Similarly, person versus location. Washington is an example for this ambiguity. It can be a person name as well as it can be a location name also. Person versus month. June can be a person name. It can be a month name. Person versus organization. AMRITA again is a person name as well as an organization name. So we can use a lot of technologies or algorithms or methods to resolve these issues. One of the methods to resolve this issue is using a kind of tagging called BIO tagging. So syntax parsing. Syntax parsing is another NLP task. It explains how the sentences are structured. Okay, this example: does this flight include a meal? Okay, so does is an auxiliary verb. Sentence can be split into three: an auxiliary verb, a noun phrase, and a verb phrase. Again, this noun phrase can be split into two: determiner this and a noun. Verb phrase can be split into verb and noun phrase. Verb is an include and noun phrase again a determiner and noun, a meal. So these are the rules, simple rules for syntactic parsing. A sentence we can split a sentence into three different ways. One is noun phrase and verb phrase. Okay. Or we can split a sentence as auxiliary, verb, noun phrase, verb phrase. A sentence can also be a verb phrase. In this case, a noun phrase can be a pronoun itself. Okay. Or it can be a proper noun. Or it can be a determiner and nominal. A nominal can be a noun. In this case, this flight, it's an example of noun phrase, determiner and nominal. Nominal is a proper noun. Okay, so nominal can be a noun, or nominal can be a nominal noun, or a combination of noun. Okay, or we can consider nominal as a nominal and PP. PP is prepositional phrase. Prepositional phrase contains a preposition plus a noun phrase. A verb phrase can be a verb or a verb phrase noun phrase combination, or a verb phrase noun phrase prepositional phrase combination, or a verb phrase can be a verb plus prepositional phrase, okay, or a verb phrase plus prepositional phrase. Prepositional phrase always has this one structure. It contains a preposition plus a noun phrase, okay. And dependency parsing. This will also give you a tree structure of a sentence. Dependency parsing will give you more information related to the how words are related in a sentence. Okay, so usually the root of the dependency parsing tree is main verb of the sentence. Here I prefer the morning flight to Denver. Here the root is the prefer. It is the main verb of this sentence. So this prefer word or verb is directly related to the subject I, and the direct object to which it is related is flight. Okay, that is direct object. This flight is modified in two ways. It's the morning flight, and that flight is flying through the Denver. So we can modify the flight in two ways: the morning and through Denver. So the determiner associated with this modifier morning is the, and the we can have one case here. Case can be a preposition or a postposition or some case markers. When you translate this into Malayalam, Denvarilude. Okay, that lude is a postposition in Malayalam. When you translate through to Malayalam, so you can translate it as lude, ude, or kind of things. That is a postposition in Malayalam. Through is a preposition in English. So case can be preposition or postposition or other case markers. So these are some relationships and their descriptions. You can find the more descriptions and or relations and descriptions in the universal dependency website. Okay, this is we have already seen this thing, word sense disambiguation. So I will give you some examples to that. Given the actual definition is, given a word in a context, we'll have a set of senses associated with that particular word. So based on the context, the algorithm, or we should understand the sense of that particular word. Then only we can understand the proper meaning or context of entire context of the sentence. One example is, I am going to read a book. I am going to book a ticket or bus ticket. So in this case, book is having two different part of speech. In one case, it is a noun, and in the another case, it is a verb. So based on the context, we identify the meaning of the word book. So this task is very important in machine translation, question answering, and speech synthesis. I'll give you one example. Consider the preposition to. I am going to Kannur. I am going to the doctor. So when you translate these two sentences in Malayalam, okay, to Kannur, Kannuri lake boy, we add a postposition lake with the word Kannur. In the next case, I am going to the doctor, and ഞാൻ ഡോക്ടറിന്റെ അടുത്ത് പോയി. ഇന്റെ അടുത്ത് postposition is added to the word doctor. So based on the context, based on the word Kannur and the doctor, the meaning or sense of two is getting changed. So since the sense of these two and two in these two cases are changed, the translations are also different. So word sense disambiguation has a lot of significance in NLP applications. And another application is sentiment analysis. So it's a most common application related to the social media text analytics. It is a task to identify and extract sentiments expressed in a text. So what are our opinions towards a text? The sentiments can be positive, negative, and neutral. We can also identify the degree of statement. It's highly positive, mildly positive, highly negative, etc. We can give some scores to that also. So the sentiment analysis task is also called opinion mining, since it includes identifying attitudes, emotions, and opinions of a company's product, brand, or services. So some companies identify some, based on the users review, they will identify some influential users. Okay, they will give some more preference to the scores or rating or reviews given by the influential users. So those scores are called influential scores. So example for sentiment are, I really love the movie. It is a positive statement. I am not sure if I like the movie. It's a neutral statement. The movie is very bad, negative statement. Okay. Other applications related to social media text analytics is emotion identification from the social media post, hate speech identification in the social media post, fake news identification in the social media text. Okay. Another, the most important application of machine translation, NLP task is machine translation. So machine translation is the automatic translation of text in one language to another. So there are a lot of approaches towards this machine translation. In earlier days, the researchers were using rule-based systems. They define some linguistic rules. If this condition satisfies, translate the word into that particular word. Kind of rules will be there. So this requires a lot of linguistic knowledge in both languages. It also requires computer science capabilities. So the researcher should understand the languages. Also, he has to convert the rules into computer science or programming language form. So it is also a very time-consuming process. Okay, defining the rules and convert it into programs, a very time-consuming process. And if you miss a single rule, you'll be in trouble. The system may not be able to translate properly. So during the 90s, people started using statistical methods for machine translation. So given a source language sentence, the statistical methods try to maximize the probability of getting the target language sentence. So you will give a sequence of source language. For example, if you are translating sentence in English to Malayalam, given a sequence of English words, the algorithm will try to find the sequence of Malayalam words with the maximum probability. That sequence of words will be generated as the translated output. So this task requires sentence in both source target languages which convey the same meaning. So that collection of document is called parallel corpus or bilingual corpus. So statistical machine translation systems require parallel corpus for dealing with the or learning the translation effectively. So they usually do the translation by dividing the sentences to n-grams. N-grams means a sequence of n-word chunks. So the other versions of statistical machine translation systems are phrase-based SMT and factored SMT. In phrase-based SMT, the machine translation system tries to translate phrases. Instead of the entire sentence, they try to translate phrases. In factored SMT, we can add more linguistic information like part of speech tags, syntax information, or dependency tag information. All those information we can add to the SMT system. So we'll get more or better translations. So nowadays we are using neural networks for machine translation. The algorithm is called neural machine translation system. So the backbone of any neural machine translation system is an encoder decoder based model. In encoder decoder based model, we have two. Actually, the neural machine translation works on a single large neural network, but it contains two different networks. One is encoder and a decoder. We can define or design these two networks using deep learning algorithms like recurrent neural network or long short-term memory networks or its other variants. Okay, encoder reads the sentence and converts it into a single contextual vector. So we assume that this single contextual vector contains the entire meaning of the input sentence. The decoder starts generating the target language words based on the single contextual vector generated by the encoder. Okay, this approach is also called sequence to sequence learning or end-to-end learning. Okay, so why it is called end-to-end learning is the entire translation, we don't have any intermediate representation. Directly translate English sentences to Malayalam sentences or source language sentences to target language sentences. Since deep learning algorithms are data hungry, this neural machine translation system require huge amount of parallel corpus to learn the proper translation. Okay. To improve the translations, we can use technologies like attention mechanism and transform model. The advantage of using attention mechanism is we can focus on certain parts of the source language sentences to understand the meaning of the source language sentence. When we generate target language sentence or words, we can selectively focus on the source language words which are contributing to the meaning of the target language words. So transform model it brings parallelism in the machine translation systems. Actually, the deep learning algorithms like a recurrent neural network and long short-term memory network has some sequential behavior in nature. So since they are having these sequential behavior nature, we won't be able to implement parallelism in the NLP system. So transform model removes the LSTMs or RNNs from the encoder decoder networks, and it use attention mechanism alone to implement this encoder and decoder network, so that they can implement parallelism. They can capture the long-term dependencies in the or they can capture the long-term dependency in the text. Other NLP applications are paraphrase detection. So paraphrase detection is checking the similarity between two texts. Okay, morphological analysis, how words are formed in a language. Morphological segmentation is there. Morphological synthesis is there. Morphological segmentation is splitting of words into root word and morphemes. Morphological synthesis or morphological generation is the task of joining the root word and morphemes to generate different word forms. Okay, so morphological analysis will give you a detailed information about the word. For example, English word played. When you split played into play plus ed, ed is a morpheme. Ed represents the past form of the verb play. So when you analyze this word played, we will get more information like when you add ed to the word play, we will get the past form. Similarly, reader. When you add er to the word read, okay, read is a verb, reader is a noun, we will get a noun form of the verb read. So you can infer that when you add er to the verb read, we will get a noun form. Question answering. Question answering is commonly used in chatbot thing or conversation agent thing. Text summarization, getting a summary of the text. Fake news identification. this is very important task in NLP, identification of the fake contents in the social media text, and author identification, identifying the author of a text. So all these applications has their own significance in natural language processing. So we have seen this encoder decoder model in neural machine translation systems for most of these tasks, like question answering and text summarization. We can use encoder decoder architecture for implementing this thing. So in question answering, the encoder considers in questions as input, and the decoder outputs the answers. Okay, text summarization, input will be a huge text and output will be a summary of the text. So the encoder encodes the entire document into a single vector. Okay, from that single vector, the decoder starts generating the summary of the text. Okay, so these all are the applications related to this NLP. So that's all about my talk. If you have any queries related to this, please ask. Hello?
Hello.
Ah,
Sir, can you hear me?
yeah, I can hear.
Sir, this is Guru Amal from Tiruvannamalai.
Okay, ma'am.
Sir, I am doing research on autism in children. So,
Okay, ma'am.
can we do the speech processing in normal laptop system? Otherwise, we need GPU or like that, sir. High-end system we need.
If you are applying deep learning kind of algorithms, I would suggest you should use GPU systems.
Okay, sir.
Okay, if you don't have GPU system in your laptop, you can use Google Collaborator. It supports GPU as well as TPU. So you can run your codes in Google Collaborator for free.
Okay. Okay. Thank you, sir. Thank you, sir.
Okay. Any other queries?
Hello, Professor.
Sir, one more question, sir. Excuse me,
Yeah.
sir. Sir,
Yes,
speech and language processing with the help of Python, can you mention any one book, sir?
Natural language processing using Python textbook is there. You can. It's published by Packet Publishers.
Okay, okay, sir.
Okay.
Okay. Thank you, sir.
Okay.
Hello.
Hello, sir.
I want to know about more in character level processing in natural language. Can you suggest me some resources to make spell checking type system?
So for a spell checking, you can use a language modeling concept. Language modeling can be defined in multiple ways. Okay, language modeling for a given sequence of characters or a given sequence of words, the language model can predict the next sequence of characters or words. Okay. Language can also be defined as for a given, it will compute the probability of a given sequence of words. So to understand more about language modeling and this kind of applications, you can refer the book Speech and Language Processing by Dan Jurowski. Online versions are available. Freely downloadable versions are available. Yeah.
Okay.
Sir?
Yes.
When the children are producing or when they are speaking sentence wise, sometimes they won't form a correct sentence. So to analyze the grammatically or syntactically, semantically, can we check at least when they are speaking a single sentence, word?
Your voice is breaking.
Or not like that.
Ma'am, your voice is breaking. I'm not able to hear you.
Right. Ask the
Can you please use the chat box? I am not able to hear you, ma'am. Your voice is breaking.
Participants, if you have a network issue, you can you can type your queries in the chat box. Premjith queries
Okay, sir.
from Lijas Babu is asking, please suggest some online courses.
Okay, in Coursera, you can find one course on natural language processing. They cover all the latest technologies in NLP, starting from the conventional way of representing words to the latest way of word representation. And they will teach you how to build a chatbot using TensorFlow. Okay. So I suggest the natural language processing course by Coursera, and some courses are freely available in YouTube. One is by speech and language processing course from Stanford University. You can follow those courses in YouTube. They are freely available.
Okay, we have one more query. Can we analyze the speech of children syntactically and semantically?
We can, but the problem is we should have some corpus. We have to collect some speech signal from these children, and we should apply some algorithms to learn those syntax and semantics. We have some technologies. We can convert speech signal into text, and we can analyze the speech signal, but we need some data to learn it effectively. It is possible.
Okay, another query. What is the future of NLP? Can we add deep learning?
Yeah, NLP has a huge potential because wherever we use language, we can apply NLP. NLP is going to be like artificial intelligence. NLP is going to be a common sense. Actually, everyone should learn NLP as a part of the course, engineering course. Nowadays, NLP technologies are using deep learning algorithms. With the we have a lot of data for most of the applications, many of the applications. So we can use deep learning algorithms. So here, machine translation, text summarization, and applications like that, we should apply deep learning architectures to learn more features or for getting more or effective outputs. We need deep learning algorithms. We can apply deep learning, no problem.
Okay, Premjith, I think we are done with the questions.
Okay.
On behalf of Department of Computer Science and Engineering, LBS College of Engineering, Kasaragod, I would like to thank Premjith B for arranging this session. Thanks to all the participants. Now you can also send your queries through email, so we will be responding to that also. Thank you all. Thank you, Premjith.
Thank you, sir. Thank you for inviting me. Thank you, participants.